all of you are doing good. Let's start today's chapter, parallel lines. Introduction. In our previous classes, we have learnt about parallel lines, transversals and some of their properties. In this chapter, we shall learn some more properties relating to parallel lines and apply this knowledge in number 1, dividing a line segment into a number of equal segments, and 2, dividing a line segment in a given ratio. A brief review. We already know the following facts. Number 1, parallel lines. Lines in a plane which do not intersect are called parallel lines. 2, transversal. A line which intersects two or more given lines at distinct points is called a transversal to the given lines. 3, distance between two parallel lines. The distance between two parallel lines is the same everywhere and is equal to the perpendicular distance between the two parallel lines. 4, if two parallel lines are intersected by a transversal, then number 1, the angles of each pair of corresponding angles are equal. 2, the angles of each pair of alternate interior angles are equal. And 3, interior angles on the same side or the transversal are supplementary. 5, if two lines are intersected by a transversal, then they are parallel if any one of the following is true. Number 1, the angles of any pair of corresponding angles are equal. 2, the angles of any pair of alternate interior angles are equal. Okay. And number 3, the angles of any pair of interior angles on the same side of the transversal are supplementary. Supplementary means 180 degree. Okay. Lines parallel to the same line. Let's consider a fixed line L in a plane. Let us also consider two other lines M and N in the plane, each parallel to L. This M is parallel to L. Then what about M and N? Are they parallel? So let's find out. Activity 1. We draw line L on a sheet of paper using ruler and set a square. Draw two lines M and N each parallel to L. Okay. This is L. Then you have to draw parallel line M and N. Okay. Now draw a transversal T intersecting L, M and N at A, B and C, forming corresponding angles 1 and 2 at B and C. Measure angle 1 and 2 with the help of a protractor and mark the difference angle 1 minus angle 2. So we repeat the experiment with two other figures involving the same type of parallel lines and prepare a chart as here given to you. Okay, so you will observe that in each case that the difference is a 0 or very close to 0. The non-zero difference is due to inaccurate measurements. Thus, in each case, angle 1 is equals to 2. As angle 1 and 2 are corresponding angles, it follows that in each case, M parallel to N. Okay. Next, lines perpendicular to the same line. Let us consider an activity. Draw a line L on a sheet of paper. Take 2 points P and Q on it. Using a ruler and set a square, draw two lines perpendicular to L forming corresponding angles 1 and 2. We note that angle 1 is equals to angle 2 is equals to 90 degree. We may repeat this activity with perpendiculars drawn at a different point on line L. In all cases, we find that angle 1 is equals to angle 2 is equals to 90 degree. This activity illustrates that two lines which are perpendicular to the same line are parallel to each other. Okay, let's consider a few examples. Example number 1. In this figure, as you can see, angle 1 is 60 degree and L is parallel to M and M is parallel to N. So we have to find angle 2. Okay. See, L is parallel to M and M is parallel to N. It is given. Okay. Therefore, L is also parallel to N. Lines parallel to the same line are parallel to each other. Remember that. Okay. That means angle 1 and angle 2 are corresponding angles and therefore these two angles are equal. So angle 1 is 60 degree and angle 2 is also 60 degree. Reason, corresponding angles. Right. Let's do exercise 18.1. In the adjoining figure, AB is parallel to CD. Okay. AB is parallel to CD and EF is parallel to AB. Is EF parallel to DC? Yes, it's parallel. Why? Reason is given here. Same lines parallel to the same line are parallel to each other. And number 2, name all the parallel line segments in the figure given below. Okay. DC parallel to EF, EF parallel to AB, DC parallel to AB. Right. So you will write all the pairs. Okay. Intercepts. If a transversal T intersects two lines L and M, in two distinct points. Okay, this is the transversal and it is intersecting at point A and B. Then the lines L and M are said to make an intercept AB on T. Okay, AB, intercept AB on T. Equal intercepts property. Draw any line P on it. Take 3 points A, B and C. Okay, such that AB is equals to BC. Through A, B and C respectively, draw lines L, M and N parallel to each other. See, these three lines are parallel to each other. Thus, we have a transversal P intersecting three parallel lines L, M and N such that AB is equals to BC. Okay. Now, draw another transversal Q intersecting lines L, M and N at E, F and G. So, now measure EF and FG. EF minus FG. Now, repeat this activity twice more and tabulate as follows. Okay. So, what do you observe? In each case, we observe that EF minus FG is equals to 0. So, this activity illustrates the following proposition. If 3 or more parallel lines make equal intercepts on one transversal, then they may make equal intercepts on any other transversal as well. Okay. So, this property is called equal intercepts property. Next is proportional intercept property. Activity. Draw any line P and take 3 points A, B and C on it such that AB is equals to X. Okay. AB is equals to X given here, say 3 centimeter, and BC is equals to Y, which is 2 centimeter. Through A, B and C, draw lines L, M and N parallel to each other. Thus, we have a transversal P intersecting parallel lines L, M and N such that AB by BC is equals to X by Y is equals to 3 by 2 in this case. Now, we draw another transversal Q intersecting lines L, M and N at E, F and G. Meanwhile, E, F and F, G, then find the difference, X by Y minus E, F upon F, G. So, we repeat the activity after taking different values of X and Y and tabulate the result as shown on the next page here. Okay. So, what will you observe here? You will observe that in each case X upon Y minus EF minus FG is 0. So, in other words, X by Y is equals to EF upon FG is equals to AB by BC. So, this property holds good for more than 3 parallel lines also. Thus, we have the proportional intercepts property as 3 or more parallel lines intersecting any 2 transversals make intercepts on them in the same proportion. Now, we shall consider some examples. Okay. Example 1 is A and B are points outside line L. Okay. This is the line L, and A, B, C, these are the points outside this line. And C is the midpoint of AB. This is the midpoint of AB. Now, AD is perpendicular to line L and BF is also perpendicular to line L. Okay, and C is also perpendicular to L. Now, first is AD parallel to CE? If yes, then why? Okay, so AD is perpendicular to L and C is perpendicular to N. Therefore, AD is also parallel to CE because line perpendicular to the same line, right? Next is AD parallel to BF? Why? See, AD is parallel to L and BF is perpendicular to L. As you can see, BF is perpendicular to line L. So, therefore, AD is parallel to BF because lines perpendicular to the same line. Similarly, third is AD is parallel to CE parallel to BF. Why? See, since AD is parallel to CE and AD is parallel to BF, therefore, AD is also parallel to CE parallel to BF. Again, same reason. And number 4 is E the midpoint of DF? Okay, why? See, for 3 parallel lines AD, CE and BF, AB is a transversal. Okay, AB is a transversal such that AC is equals to CB. Hence, E is the midpoint of DF, right? Similarly, you will do other example also. Okay, exercise 18.2. In the figure, PQ parallel SR. TU is parallel to PQ and T is the midpoint of SP. Is PQ parallel TU parallel SR, why? Okay, we have to tell is PQ parallel to TU parallel to SR. Similarly, we've done example number 1. So this question is similar to example 1. Okay, and number 2 is use the midpoint of QR. U is the midpoint of QR. Of course, it is a midpoint of QR, but you have to give reasons here. Okay. Dividing a line segment into equal parts. Now we shall learn how to divide a line segment into any number of equal parts using a ruler and compass. We shall illustrate the process through an example. Okay, example is divide a given line segment AB of length 8 cm into 4 equal parts. Okay, so solution here is given. We follow the steps of constructions given here. Number 1, draw AB is equals to 8 cm. 2, draw ray AC such that AC is not in the same line as AB as shown in figure. 3, on ray AC starting from point A, make 5 equal line segments AC1, C1, C2, C2, C3, C3, C4, C4, C5 of any measurement with the help of compass. Join C3B. Okay. Number 5, through the points C1 dash, C2 dash, C3 dash and C4 dash, draw lines parallel to C5, B intersecting AB at points B1 dash, B2 dash, B3 dash and B4 respectively. Line segments A, B1 dash, B1, B2 dash, B2, B3 dash, B3, B4 and B4B are the required equal parts of AB as you can see in this example. Okay, here is alternate method also given, so you have to go through these steps of constructions. Okay, next, dividing a line segment internally in a given ratio. We shall explain the method by the help of an example. Okay, so example is we have to divide a line segment AB of length 7 cm internally in the ratio 3:4. So we follow the steps given below. Number 1, draw the line segment AB of length 7 cm. 2, draw a ray AC such that AC is not in the same line as AB. 3, on the ray AC make 7, that is 3 plus 4 equal line segments. Why 3 plus 4? Because we have to divide in the ratio of 3:4. So A, C1 dash, C1, C2 dash, C2, C3 dash, C3, C4 dash, C4, C5 dash, C5, 6 dash and C6, C7 and C7C using compass. Now join B, C7 dash. 5. Starting from A and counting 3 line segments drawn, we reach C7 dash. Through this point, draw a line parallel to C7B intersecting AB at P. So P divides AB in the ratio 3:4 or AP upon PB is equals to 3/4. Okay, alternate method is also given here. So go through these steps. Okay, exercise 18.3, you have to draw a line segment AB of length 9 cm and divide it into 3 equal parts, measure each part. Okay, students. Now, things to remember. Number 1, 2 lines which are parallel to the same line are parallel to each other. Remember this always, okay. Number 2, a straight line which cuts 2 or more straight lines at distinct point is called a transversal. 3, 2 lines which are perpendicular to the same line are parallel to each other. Also remember this line. 4, if a transversal T intersects into 2 lines L and M in distinct points A and B, then the lines L and M are said to make an intercept on L. 5, 2 parallel lines make equal intercepts on all transversal perpendicular to them. 6, equal intercepts property. What does it say? If 3 or more parallel lines make equal intercepts on one transversal, then they make equal intercepts on any other transversal as well. 7, proportional intercepts property. 3 or more parallel lines intersecting any 2 transversal make intercepts on them in the same proportion. 8, we can divide a given line segment into a number of equal parts using equal intercepts property. 9, we can divide a given line segment in a given ratio internally using proportional intercepts property. Students, here comes the end of this chapter. Now you will do practice of the remaining questions and do practice of the construction also.